Anyways, so we're going to talk about non-homogeneous linearities, and this is exactly the way it was in chapter 2. There's nothing really changed. Now we have a standard form, which I think I need to use the other standard. So here we have a non-homogeneous linear ODE with constant coefficients, where each of these are constant, and here this can be some function of x. Here we still have the same basic rules. So the basic rule, if it's simple and close enough to y of p, so here what we're going to choose for our particular, if it's real close to this, we can just use the simple modification rules. If it's part of the homogeneous, we keep adding x until it's not. And some rule, if we have two of them, if we have like e to the x, so like if we have e to the x plus x squared, we're going to guess some k e to the x plus some k1 or k2, I guess, e to the x squared plus k1 e to the x, or x plus some k0. So these are the rules that we'll be using. Let me get rid of that. So these are the same basic rules. And so here's what we're going to choose. This is what we're solving, right? And this is the little sheet I gave you last time, right? If it's e to the x, it better look like you guessed some k e to the x. If it's some x to m, you guess that polynomial down. So every power load in that. If it's sine and cosine, you're going to guess both sine and cosine. So even if it's just cosine, you're going to have to guess both sine and cosine. And here if we have the complex version, right? Or what we know gives, so e to the ax and cosine, we guess both of these. So how do we solve these? Here are the steps. I'm going to write them out in nice, clear order. Step 1, solve for the homogeneous H1 by using the characteristic equations. So this is what we used last time. So that was the last chapter, right? Step 2, solve for a single solution, a single non-homogeneous solution, YP, using the method of undetermined coefficients, same as 2.7. We're going to add them up and then solve the initial value problem using initial conditions. So this is exactly, your method is going to cover variation parameters. We're not going to go over this. We're just not. So we're just going to do these steps. So step 1 through 3, if it's that. And so this is literally no different than 2.7. The only difference is we now have, instead of just 2, it can be nth order. That's the only difference. All right, so let's do 2 of them. And then we'll let you guys go and do the rest for homework. All right, so we're going to find the general solution of this. All right, so we're going to do step 1. All right, so step 1 here. So step 1 is find the characteristic equation and solve for YH. So let's solve for YH. So step 1 is find my YH, which is Y homogeneous. So here we have lambda cubed plus 2 lambda squared minus lambda. Oops, I'm on the wrong layer. Minus lambda plus 2 equal to 0. And we're going to solve the homogeneous. So you set this equal to 0. And so everywhere you see a y whatever prime, that is lambda to whatever power. So if this is the third derivative, this is lambda cubed. Why? Because what are we guessing? Remember what we're guessing. We're guessing y homogeneous is something e to the kx. That's what we're guessing for the homogeneous case. We're trying to figure out what e to what kx. Okay, so that's where this comes from. So all you really need to do is write this down. Then you solve it. Solving this gives us our following. You do not need to show me how to solve any polynomials in this class. You do not need to factor. You don't need to do anything. You have a calculator. You're engineers. Type in a calculator. Okay? If you guys work a job where you're not allowed to use a calculator, email me. I've taught thousands of students. I have never received an email yet. Anyway, so step 2. All right, so step 2. So here we get the initial value. So we get this and we just plug it in. So we have 1. For some reason, I ran this backwards. I don't know why I ran it backwards, but I did in my notes, so I'm going to keep it that way. Rule of thumb: if you do something in your notes one way, don't leave your notes when you're trying to do high-end differential equations, because you'll get lost. because you're so focused on teaching, you're not focused on what you're doing, aka the math. All right, so here, so once we do this, we get this general solution. So now our y particular. So what are we guessing in this case? Well, in this case, I have cosine of 2x. So what I need to guess in this case is k1 cosine of 2x plus some k2 sine of 2x. Okay. And the reason is, let's go back to this. So if you see either sine or cosine, you have to guess both. Why? Because let's look right here. If I guess cosine, the second derivative give me cosine again, but the third derivative, oh, I did this wrong, didn't I? This is not right, typed right. This should look like this, guys. I was like, this is a correct characteristic equation, but this should have a y prime, this should have a double prime. Because if I had a 2 here, that technically that 2 should have got moved over here, right? This is the correct way. Oops, hi. Come back. So this is correct. So it should be y triple prime plus 2y double prime minus y prime plus 2y. Okay. All right, so here, so since we only have cosine, we still have to guess both, because if this was cosine, if I took its derivative, this becomes sine, so I have to cancel out that sine somehow. So that's why we guessed both. So what do I need in this case? I need all the way up to y triple prime. So I'm going to just calculate that out real quick. So y prime is equal to 2, oops, is equal to minus 2 k1 sine of 2k plus k, or 2k2 cosine of 2x. Y double prime is equal to minus 4 k1 cosine 2x plus, nope, in this case, minus 4. Whoop, hey, don't do that. 4k2 sine of 2x. And then we'll take its derivative one more time. Triple prime 8k1 sine of 2x minus 8k2 cosine of 2x. Yes. Okay, I'm just double checking. Okay, so once we have all these, what do? We plug it in. We plug all this into here. So I'll have 8k1 sine of 2x minus 8k2 cosine of 2x plus 2 times minus 4k1 cosine of 2x minus 4k2 sine of 2x. So here I'm just, where I see the double prime, I'm plugging in double prime. Here for the y prime, I'll plug in that, so it'll be minus 2k1 sine of 2, oops, plus 2k2 cosine of 2x plus 2 times y, which we just read right here, k1 cosine 2x plus k2 sine of 2x. There we go. So what is, and this is going to equal what? This equals cosine of 2x. All right. In fact, here, oops. Let me be a little bit more clear. I'm going to say this is all equal to cosine of 2x plus 0 sine of 2x. And the reason I want to put that 0 there is that way I can be very clear when I collect things. So what am I doing? I just plugged this into here, this into there, this into there, this into there. And now I'm going to collect everything. So I have 0 on my sign, so we're going to collect all my signs. So here I have 8k1, 8k1, minus 8k2. And here I'll have a sign. And so this is minus and minus. So that'll be plus 2k1. And then here I'll have 2k2. So here I collected all my signs. And here for my cosine, there's technically a 1 there. Let's look at that. That's minus 8k2 minus 8k1 minus, so it'll be minus 2k2 plus 2k1. So everyone see where I get these? How I produce this. Any questions on that? So I'm just saying I'm just saying my cosines. All right, so my first one was sine, so 0. So all my signs better, all these better equal to, all this better add up to be 0 because I need to have 0 sign at the end. And all my cosines better add up to be 1 because I have 1 cosine at the end. That makes sense?
2k2 for sine.
What?
That's for the 0 equals 8k1 minus 8k2 plus 2k1. It should be 2k2 at the end there, right?
Oh, yes, thank you. Yes, because the 2 would go into that. Thank you. And so then you just chunk it through a calculator, right? Because if you clean, chunk it through a calculator, you should get that k1 is equal to minus 1/20th, and then k2 is equal to minus 1/20th. Did I do this right? I'm going to double check. Hold on. Make sure I did this right. Because this gives me, for some reason, I don't think this is right. If this was negative, I would think it'd be right. Because then, because this would all add up to 20, but it doesn't. Did I have are my notes wrong? That's going to bug me. Let me look up something real quick. I think my notes are wrong, or at least my answers to my notes are wrong. Hold on. Let me go back. I'm going to go back to an older set of notes. When did I originally do this problem before I typed it all up? Whoa. Ta-da. Here's the handwritten. All right. So, yep. Modification rule, all this other stuff. Whoa. There's one more typo. That should be negative. Then all this works out the way you think it would work out. Sorry about that, guys. Could we solve it the way it as is? Sure. But let me just keep my cheat sheet. Good. So just make that a negative. I'll make all these edits and upload them. So with those edits, these become negative. Okay. And then we can check it out real quick. Yeah, then this works out real well because here we'll have 10k1 minus 10k2. That means k1 equals to k2, which we have here. And then here we have, if k1 equals to k2, this would be minus 20 equals 1, so it would be negative 1/20th. Can I show my correction again? Yes. Let me just rewrite this as clear as possible. So this is y double triple prime plus 2y prime minus y prime minus 2y is equal to cosine of 2x. Apparently, when I was typing up this program, I just smashed my head against the keyboard and called it good. And didn't double check it.
Isn't that just how like math works?
Yeah. Yes, math is solved by smashing your head against keyboards until it finally comes out with the correct answer. All right. With this, we now established what K1 and K2 is. And so we have what Y of H is. You know, or Y of P. So Y of P in this case is minus 1/20th of minus 1/20th of cosine of 2x minus 1/20th of sine of 2x. And so we have our particular solution. So we're going to do step 3 here. And luckily we have room to do it. As we say, y is equal to yh plus y of p. And so in this case, it is c1 e to the x plus c2 e to the minus x plus c3 e to the minus 2x plus our particular solution, which in this case is minus 1/20th cosine of 2x minus 1/20th of sine of 2x. There we go. When in doubt, take a derivative. That doesn't work. Head to keyboard. Can I show my correction again? Oh, I think that's old. Sorry. I'm a little scatterbrained today, guys. All right, let me zoom out so you can see the whole thing at once. There you go. I'll let you copy for a second. All right. So you probably won't have too many problems on the exam. I do want to give at least 5 problems. Because if I give less than 5 problems on the exam, if you miss one, if you just totally botch one, you know, you're already in C territory or low B, I guess, right? And so it's having, I like to have a couple of things so you can miss one or two and not feel bad, but not so much you're just overwhelmed with work. All right, so that's this one. Let's do the next page and then we're done for the day. So these problems take a long time. They just do, right? Let's do the next one. So we want to solve this mess. So this one, we'll do all 4 steps. We have time to do it. So we're going to do this plus all our initial conditions. So we are going to be solving for a bunch of constants. So let's just start with step 1. So step 1, it would be we want to find y of h. And so here we have y triple. Let me double check I wrote this one correctly before I even get started. Yes, this one's written correctly. Okay. All right. So here we have this plus y. Oh, I know why this is written this way. There should be a 3 here. The 3y lambda plus 1 is equal to 0. So this is our characteristic equation for this differential equation for the homogeneous, right? We solve for this, we're going to get y plus 1 cubed is equal to 0. This is binomial expansion. Hopefully you can recognize that. If not, that's what the calculator is for. So lambda 1 equals lambda 2 equals lambda 3, which is equal to e to the minus x. So what do we have here? So our y homogeneous is c1 e to the minus x plus c2x e to the minus x plus c3x squared e to the minus x. Remember, every time we add, every time we have a repeated, whoa, I'll just give you the answer. What have I done? What? Oh, hold on, I need white real quick. White me. All right. It's equal to 1, or minus 1, sorry. Doesn't equal, I solved it. Lambda 1 equals lambda 2 equals lambda 3 equals negative 1. So since this appears 3 times, we add an x every time we see it. Okay. Step 2 is we're going to find our y of p. So in this case, what are we going to guess? Well, we want to guess this, right? We're going to guess that y of p is equal to some k e to the minus x. Well, is that what we're going to guess here? And the answer is no, right? Won't work. I'm going to say won't work. And why won't it work? If we guess this, what should we get? Well, this is a homogeneous solution, right? We're going to get 0. So that won't work. So this won't work. So we have to multiply by x. How many times? Not once, not twice, but 3 times, right? We have to do this 3 times, right? And so our y particular guess in this case is going to be kx cubed e to the minus x. Does everyone see why that is? Because this is because e to the x is a homogeneous one. So if I plug that in, I'm just going to get 0, right? I'm not going to be able to get the 30, right? Plug in e to the x, that's also homogeneous. So that's going to give me 0. So that never will get me to 30. X squared will do that, so that won't work. So we keep multiplying x until we have a non-homogeneous solution. In this case, we have to go 3 times, right? Until we get to this. So once we have this, we need to find its derivatives. I need to find up to 3 derivatives. So the first one is k. And here we'll have, once again, this will be product rule. So it'll be 3x squared minus x cubed e to the minus x. You can derive that via product rule. Double prime will give me k of 6x minus 6x squared plus x cubed e to the minus x. Y triple prime is equal to k. And you can also use your calculators to find your derivatives. I'm not opposed to it. I assume you know how to find a derivative. That might be a big assumption. Oops. Okay, so here we have this. All right, so now we plug it all in. I'm going to have k, and so I plug it all into this up here and solve. So here I have k.
Is that a 4 or a 9 after the 18x?
That's a 9, sorry. If you ever have any question about my handwriting, says please ask me. It's getting kind of chunky. It's getting kind of chunky, so let me hello. Let me export some stuff so it gets less chunky. Goodbye. Yeah, don't save. Hey, you. Export. Save. Goodbye. Don't save. Okay, so just plug all this in. So here we have what plus 3 times this one, so it'll be k. I'll just put in, it'll be 3k since it's already multiplied. I won't put the extra set of parentheses. Plus 3k, 3x squared minus x cubed, e to the minus x, plus x cubed, e to the minus x. And all this is going to equal 30 e to the minus x. And so here, all the e, the x's, e to the minus x cancel. And then if you work through all of this, It ends up being a big mess, but once you work through all of it, you just get k, or you get 6k is going to equal to 30, which means k is equal to 5. So y in particular, a lot of stuff ends up just canceling. The only thing that ends up surviving is this, because all the other parts cancel. And then here you get 5 x cubed e to the minus x. Okay. And here we do step 3. So step 3, we just put it together. So we have y equals y of h plus y of b. And so here we have y of h is up here. So we c1 plus c1 e to the minus x plus c2 e to the x e to the minus x plus c3 x e to the minus x plus 5. That should be squared, sorry. 5x cubed e to the minus x. All right. Are we done? No. Step 4. Have room to do this step? All right, so step 4, we're going to find out what C1, C2, and C3 are. And we're going to be using this up here. All right, so we're going to have y of 0 is equal to 3, which is equal to C1 plus 0 plus 0 plus 0. So this is just C1, correct? Everyone see how I got that? I'm in trouble. I'm in trouble. Hold on, let me see something really fast, just to make sure I'm not goofing something. Okay, so let's do the next one. All right, so let's do the next one. I have y prime of 0 is equal to minus 3. All right, so what's y prime here? So if I take the derivative of this, I just get c1. The derivative of this gives me what? This will give me c2 e to the minus x plus x, and it doesn't matter from there. And in fact, everything else from here dies, if you believe me on that, because everything else will at least have one x in it. And if it has an x in it, it's going to go to 0. So everything else disappears. So in the end, this is just C1 plus C. Hold on.
Shouldn't the C1 be negative when you take the derivative?
Yes. Hold on, let me. My brain is full of. I had it. I literally had it. And then it's what I do. Hold on. No, C1 is positive. Let me double check that. So C1 is positive. Why? Because here, let's look at this. Here, this e to the x. Oh, the C1 is negative and the C2 is positive. Correct. Thank you. Because this one comes out to be C1, but this one, I take this derivative and hold this constant, which gives me the C2. So that means, so this, plug this through. So C1 is equal to 3. This tells me that C2 is equal to negative 3 plus 3. So C2 is equal to 0. Okay. And then let's look at y triple prime. Y triple prime. or y double prime, sorry, of 0. And that is equal to minus 47. All right, so let's figure this out. So here, if I take this derivative 3 times, what do I get? I'm going to get, if I take this derivative 3 times, what do I get? I'm going to get positive c, or no, not 3 times, twice. I'll get positive c1, correct? c2, I know this term is now 0, so I never have to take a derivative of it ever again. I know it's 0 because c2 is defined to be 0, so it's just gone. So don't worry about it. Look at this one. Here, since I have x to the third, this will never produce, this will always have a term of x in it, so it'll always be 0. So we don't need to figure that one out. Here, if I took the derivative of, if I took partial derivative, if I took derivative of x and did product rule, it's when this one went twice is the only one that won't have an x with it. And so this would be plus c3. But the 2 will come out. So it'll be plus 2c3. And here I'm just trying to, because here, if I took the derivative here, I'll get c3 or 2x plus e to the minus x, and the other one will have x squared in it, which will never go away. And then if I took this derivative again, then I'd have e to the x. And so I have the 2. And so I'm left with this. And so here, if I move the 3 over, I'll get 20, I'll get negative 50, and then negative 50. So c is equal to minus 25. So c3 is equal to minus 25. And so here we have our answer. Once we have all that. So we have 3e to the minus x minus 25 x squared e to the minus x. That should be negative. Sorry about that. And then plus 5x cubed e to the minus x.
So if we had left the y particular as k e to the negative x, at what point would we realize that that wasn't the right y particular?
Because if you plug that in, you're going to plug it into here, and you're going to realize that everything just zeroed out. You're going to have 0 equals to 30. Because if it was a homogeneous solution, it by definition zeroes out. So if you get 0 equals to whatever, just slap an x on it. If it still get a 0, slap another x on it. Okay?
Yeah, that's what I was wondering. So it's kind of trial and error unless you realize it.
Yeah,
right
so
away.
unless you realize, because what happens here, because I chose this problem because everything that can go wrong goes wrong. So here we have repeated values, so we need to add more x. And then here, since this e to the is one of the homogeneous solutions, we have to add x. But if we add x, that's still a homogeneous solution. And that's still a homogeneous solution. You have to do it 3 times before you leave the homogeneous solution land. Does that make sense now?
Now I get what you were saying. Because the e to the x itself is what we're using in the homogeneous part.
Yeah. Yeah. So since that's part of the homogeneous solution, we have to keep adding x's to